Hello everyone and welcome back to Nile Certify. In this video we will continue on discussing practice questions for Azure 104 Azure Administrator exam, and in today's video we will tackle domain 3, which is about deploying and managing Azure Compute Resources. So without further ado, let's go and tackle the first question. So the first question here says, you manage a bicep file that deploys 5 web apps for one team. The team wants a single scaling service and the lowest possible cost. What should you ensure in the template before deploying the web apps? A. Define one server farms resource and reference its ID from each Microsoft.web/sites. B. Define 5 Microsoft.web/server farms, one per web app. C. Add an application gateway and reference it from each site. D. Add a traffic manager profile throughout across the site. So in this question here, we are deploying 5 web apps with Bicep. The team wants one place to scale and the lowest possible cost as well. The keyword I'm really interested in are single scaling services and lowest cost. So before breaking down the option, let's have a quick review here. Server farms. What are server farms? We see it here on option A. So Microsoft.web/server farms, that's the ARM resource type for an app service plan. And what an app service plan? And the app service plan is basically it's the engine that powers the web apps. So it defines the compute region and SKUs, CVPUs, memory, and etc. And it's the unit that you scale and pay for. And lastly, is Microsoft.web site. Those are the actual web apps which attach to an app service plan via server farm ID. So app service plan equal engine, and web apps is you can think of them as the cars that share the engine. So now let's go and review the option one by one. And here first option is one Microsoft.web/server farms, and so that's the app service plan and all apps reference it. And here we have one shared engine and all 5 web apps run on the same compute pool. Also, you get one scaling service, which means just one slider to scale up or out. And also, which is really important here, you only pay only one plan, right? So that's a really low cost, and that's much the requirement that mentioned in the question. So this is so far a good answer, but we will continue reviewing the other answers. Answer B, 5 Microsoft.web/server farms, which means one per app. And on this one here, we have 5 separate engines. And each plan also scales and builds separately. So this one has advantages, some advantages. For example, if you want isolation, or there's like different SKUs that you want, but actually it conflicts with a single scaling service and also with the lowest cost, because you will be paying, as we mentioned, for 5 plans instead of just one. So option C, create an application gateway and reference it from each side. So application gateway, it's basically a load 7 or a type layer 7 load balancer, and it helps with SSL offload, routing, web security, but it does not unify app service scaling or cost. So it's actually an extra bill and it's not relevant to our requirements here. And this leaves us with option D, which is add a traffic manager profile throughout across the sites. So traffic manager, if you like, we talked about the application gateway, we mentioned it's layer 7 load balancer. Here, traffic manager is actually DNS level routing across endpoints regions, and it's usually used for global distribution or failover, but actually also it's not involved with consolidating costs or scaling. So it's also an extra bill and it doesn't satisfy the requirements. So the correct answer here is answer A, which is the correct answer. Next question. Here you need to convert an existing ARM template named app.json into bicep for review in a pull request. The file is stored locally. Which command should you run? A, as a deployment group what dash if dash dash template file app.json. B, as a bicep decompile dash dash file app.json. C, as a bicep build dash dash file app.json. And D, as a deployment subcreate dash dash template file app.json. So this question here we have ARM template called app.json on your machine. You want to convert it to bicep so you can review it in a pull request. And the question is, which Azure CLI command gets you that job done? Now let's go through the option one by one. First option, as a deployment group what if. And a what if is a preview tools and it compares your template against the current state in Azure and shows the changes that would happen if you deployed. It does not convert formats. It keeps the file as JSON and simply previews the outcome at the resource group scope. So it's a very helpful feature, but that's what does it do. Let's move to option B, AZ bicep decompile. And decompile is a key here. In bicep terms, decompile means convert an existing ARM JSON template into bicep syntax. So you point it to a local JSON file, it outputs a bicep file that you can review it in a PR. And this exactly aligns with the scenario. Local file converts to bicep reviewable code. Option C, AZ bicep build, and the build goes the other direction. It takes a bicep file and compiles it into an ARM JSON template, and here you start from JSON, no bicep. So build is the wrong tool and the input extension does not match the expected source. So this is a wrong answer. Option D, AZ deployment subcreate. And this is a deployment command at subscription scope, and it will attempt to deploy the JSON template, but it does not convert anything and it's out of scope for a code review task. So you would use this when you are ready to deploy actually, and not when you want to transform the file format. So the correct answer is B, AZ bicep decompile, because as we mentioned, decompile converts an existing ARM JSON template into bicep so you can review the result in a pull request. So key differences to remember here from this question is decompile basically transform JSON to bicep, which is great for migrating all templates and code reviews. Build is bicep to JSON used before deployment, and what if is a preview of changes and no format conversion, and deployment create actually deploys, so no conversions is involved. Moving to third questions, and it said you deploy a VM named VM1 that uses standard SSD for the operating system disk and one data disk. The application vendor asks for twice the CPU and memory for the next payroll run. You must minimize downtime. Which action should you plan? A. Resize VM1 to the next larger size in the same VM family. B. Move VM1 to a different region and redeploy from a managed image. C. Convert the operating system disk to premium SSD and change it to a different VM family in one operation. D. Migrate VM1 to an availability set, then increase the size. So here we have a VM on a standard SSD operating system plus one data disk. The vendor wants double CPU and memory for the next payroll run, and you need to minimize downtime. Which action should you plan? The keywords I would like to draw your attention to here is doubling the CPU and memory, and next run, and minimize downtime. Now let's go and review the options. So option 1, resize VM1 to the next larger size in the same VM family. And staying in the same family usually gives you a straight scale-up path. If the target size is available on the current cluster, Azure actually can sometimes resize your VM without full deallocation, which is great. But most resizes will require quick stop and start cycle. Either way, it is usually the shortest path to move a virtual CPU and RAM with minimal disruption, and also to avoid disk migrations or platform moves. And this lines up with both requirements in the question, which is doubling the CPU and memory and minimizing downtime, especially for one-time spike like payroll. So that's a possible answer. Let's continue reviewing the other options. Option B, move a VM1 to a different region and redeploy from a managed image. And this is a heavy move because you would have to capture our image and redeploy, reassign networking, and possibly change dependencies and accept a longer outage window. And it does not fit a minimized downtime requirement because region moves are for strategic locations, not quick capacity pumps for the next run. So it doesn't make lots of sense, this option. Option C, convert the operating system disk to premium SSD and change to a different VM family in one operation. Here, two things to notice. First, changing disk type and changing VM family are separate operations with different constraints. Second, switching VM family often requires deallocation and host reallocation, which increases downtime risk. Premium SSD can improve IOPS and throughput, but the question is about doubling CPU and memory, not storage bottleneck. So this option actually adds complexity without directly solving the CPU and RAM need in the simplest way. This also why it's wrong answer. Option D, migrate VM1 to an availability set, then increase the size. And you cannot place an existing VM into an availability set. So you would have to recreate it in that set, which means significant downtime. Availability set, improve fault domain and update domain placement, but they do not quickly or directly give you a CPU or RAM increase you need for the next run. And this is a conflict with minimized downtime. And after going through all these options, the best plan is option A, resizing VM1 to the next larger size in the same VM family. It directly addresses the virtual CPU and memory needs, and it's the least disruptive path. So it's appropriate answer for this question. And just let's remember that if you are resizing within the same family, usually that's the simplest way to add CPU and RAM with minimal downtime. Region moves And recreating in availability sets mean rebuilds, which means also longer outages and extra work. So those are not the first option should come to your mind. And disk type changes target storage performance. So for example, like here from standard SSD to premium SSD. So those are usually useful for throughput issues, but when not the requirement calls you to double the memory and say CPU. Moving to our next question, and you are preparing to encrypt both operating system and data disk on a set of existing Linux VMs. Security requires platform managed keys. Which two prerequisites must be met before enabling Azure Disk Encryption on these VMs? Choose two. A. The VMs must be stopped and deallocated. B. The VMs must use managed disks. C. A key vault must exist in the same region with enabled purge protection. D. The operating system must be Ubuntu 22.04 or later. E. The VM size must support TVPM. Alright, so let's break this one down. Scenario is pretty common. You have got some Linux VMs already running, and now you want to enable Azure Disk Encryption on both the operating system and data disk. The twist here is that the security requires platform managed keys. So the question is, what prerequisite do you need before you can actually turn on encryption? Option A, the VMs must be stopped and deallocated. And this one sounds right, because sometimes you do need to stop VMs for certain operations. But in this case, Azure Disk Encryption does not require you to allocate the VM. And you can enable encryption while it's running. So this one is not a prerequisite. Option B, the VMs must use managed disk. And this is absolutely required. Azure Disk Encryption only works with managed disks. If you are still on the old unmanaged disk model, encryption won't even be an option for you. So keep this in mind. This is a solid prerequisite. Option C, a key vault must exist in the same region with enabled paired protection. Now this one is interesting because the question mentioned platform managed keys, which might make you think, oh, I do need a key vault. I don't need a key vault, but in reality, even with the platform managed key, you still need a key vault for storing secrets like passphrases or BitLocker keys. And that key vault has to be in the same region as the VM, with soft delete and paired protection enabled. This is required for compliance and security, and this is another correct prerequisite. Option D, the operating system must be Ubuntu 22.04 or later. And this one is a red herring because Azure Disk Encryption supports multiple Linux distributions, not just Ubuntu. And it's not restricted to version 22.04 or higher. So this option is incorrect. Option E, the VM size must support TVPM, and VTPM is required for confidential VMs, which is a different feature. It's not requirement for standard Azure Disk Encryption with platform managed key, so this is also incorrect. And key differences to remember: managed disks are mandatory, encryption won't work without them, and key vault is still required, even with platform managed keys, and it must have a paired protection enabled. And you don't need to stop the VM, you don't need a specific operating system version, and VTPM only applies to confidential computing. Moving to question 5, you maintain an Azure Container Registry named ACR-prod. Developers must push images, pull images, and must not be able to delete repositories. Which role assignment implements least privilege? A. Owner on the resource group. B. ACR pull on ACR prod. C. Contributor on ACR prod. D. ACR push on ACR prod. In this scenario, you are running an Azure Container Registry called ACR prod, and developer need to push images and they also need to pull images, but they must not have permission to delete repos. And the question asks which role assignment implements least privilege. Let's go through the options. Option A, owner at the resource group, and this role gives you full control over everything in the resource group. Owner can create, can update, and can delete, and can even assign roles to others. So this is a massive overkill here, and not at least or not least privilege at all. Option B, SCR pull on SCR prod, which is a container. So this role only lets you pull images, and the developer wouldn't be able to push new ones, which is the question specifically says they must do. So while it's restrictive, it's actually too restrictive and doesn't meet the requirements. Option C, contributor on the container, ACR prod. So contributor gives broad access, including the ability to delete resources like repos, and this goes against must not delete requirement, so it's not the right choice either. Option D, ACR push on ACR prod, and this one is perfect. ACR push allows both pushing and pulling images, but it does not allow deleting repos. It gives the developers exactly what they need, no more and no less, and it is the correct scenario. So let's remember here: ACR pull, pull only; ACR push, push, pull but no delete; and contributor or the owner are too broad. It includes stuff like deletes or violating the least privilege principle. This is why we excluded them, and the right answer is SCR push, as I mentioned. Next question. You created an AKS cluster named AKS prod and need to deploy a YAML manifest from your workstation. You run the following: AZ AKS get credential dash dash results group RG1 name AKS prod. The second command is kubectl apply dash f api.yaml. Does this meet the goal? Yes or no? In this question, we got AKS cluster called AKS-prod or production, and your goal is to deploy a YAML manifest from your local workstations. The question shows you run two commands: AKS get credentials, followed by the resource group and the AKS cluster name, and then the other command is kubectl. So let's review the commands here. And the first command, the AKS get credentials, what does it do? So this command actually pull the kubeconfig for your AKS cluster into your local machine, so that kubectl can talk to your cluster. Without this step, your kubectl would just be yelling into the void. So far, so good. This one we needed. The second command, it takes your Kubernetes YAML manifest file and applies it to the currently connected cluster. So assuming that the API.yaml is a valid manifest and you are authenticated, then you are good to go. So does this meet the goal? Yes, 100%. You are connected, you have connected to the right cluster and applied the manifest. That's exactly what the question is asking. So just review the commands. The first command, AZ-AKS get credentials. This is about downloading the kube config and set current context. And the kubectl apply deploy your resources to the active Kubernetes cluster. And this is the standard way to manually deploy YAML manifest to AKS from your developer machine. Next question. You prepare or you operate an app service app named app1 in plan ASP-STD. Requirements: use a custom domain and a free TLS certificate. Scale out based on CPU to as many as 10 instances. Keep cost reasonable. Which change should you make first? A. Move app1 to a premium V2 or V3 plan. B. Enable always on in the current plan. C. Add a deployment slot and enable auto swap. D. Add an internal load balancer to the plan. So here we are running app service named app1, currently sitting in the standard tier, and there's big requirements. Three. One is we need to use custom domain and free TL certificate. Scale out to 10 instances based on CPU and keep the cost reasonable. And the question, and let's focus here, the question asking us what change should you make first? Alright, so let's walk through the options. Option A, move up to a premium V2 or V3 plan. And this is very promising. Why? Because standard ASP standard plan supports custom domain and free TL certificate, but it can only scale out to 10 instances, and that's the maximum limit for standard. So if you ever want more headroom or to scaling and better performance, you're gonna need to upgrade. Premium V2 V3 plan give you up to 30 instances, better scaling performance, and it still includes the free TLS and custom domains, and cost is still reasonable for production workloads. So this is a good answer so far based on the long-term needs here. But let's keep it in mind and move forward towards the other options. Option B, enable always on in the current plan. And always on is great for keeping your app warm, especially useful for background jobs or fast response times. But it doesn't help with custom domains, certificates, or scaling out to 10 instances. So while it might be a useful later, it's not addressing the primary requirement. So this one is incorrect. Option 4 or option C adds a deployment slot and enable auto swap. And this is a cool feature, but again, it's totally unrelated to the goals here. Auto swap is for release management and CI/CD, continuous integration, continuous deployment stuffs, and you are not being asked about deployments or staging slots here. So this one is incorrect. Option D, add an internal load balancer to the plan. And the internal load balancer is used with app service environment ASE for isolated network traffic, not standard or premium plans. Also, this has nothing to do with scaling or TL certificate, so it's not relevant, and we will keep the first answer as the correct answer for this question. So it's answer A. move app1 to a premium v2 or v3 plan. Moving to our next question, and here you must stage a zero downtime web release for app1. The update must be validated by the QA on the same infrastructure, then promoted with a single action if tests pass. Which two actions should you perform? A. Create a deployment slot named staging. B. Deploy the update to the production slot. C. Swap the staging slot with production after validation. D. Scale the production slot to 0 instances during the test. E. Create a new app service plan for staging. Here we have running app1 on Azure App Service, and the team wants to stage a new release. Let QA validate it on the same infrastructure as production, then promote it to production with single action. Only if test passes with no downtime allowed. And the question asks, which two actions should you perform? So let's break it down. Option A, create a deployment slot named staging. And yes, this is step 1, because deployment slots let you run multiple versions of your app in the same app service plan using the same infrastructure. The staging slot is where you deploy your new update. This keeps production untouched while QA tests the update, and this is a requirement as I mentioned. Option B, deploy the update to the production slot, and this one actually defeats the whole purpose, because we are trying to validate the update first and not push it straight to production. So this one is wrong. Option C, swap the staging slot with production after validation, and that's exactly how zero downtime release works in app service. You validate in staging, then use the swap feature to instantly move the validated code into production, and Azure handles the routing and warm up seamlessly. So this one also is required. And option D, scale the production slot to 0 instances during the test. And not only this is unnecessary, but it's also risky. Because when scaling production to 0, that's actual downtime, and that's exactly what we are trying to avoid. Option E, create a new app service plan for staging, and this one adds an extra cost and doesn't fulfill the requirement that the QA test on the same infrastructure. Slots run under the same plan. So you don't need or want to create a separate app service plan. Because it violates the same infrastructure constraint, this answer is wrong. And the correct answer would be the using deployment slots, which is A, create a deployment slots naming staging, and C, swap the staging slot with production after validation. Question number 10. You need to rapidly deploy a scale set with 20 instances and allow different VM sizes in the same set for spot and standard nodes. You also want zone redundancy. Which configuration should you choose? A, virtual machine scale set, uniform orchestration, one size only, zone redundant. B, virtual machine scale set, flexible orchestration, multiple sizes, zone redundant. C, availability set with 2 full domains and 2 update domains. D, single VM with Azure backup and ASR. Today's question is all about scaling virtual machine, mixing spot and standard instances, and staying zone resilient. So this is a very practical exam scenario, and let's break it down here. So the question is requirements, and the requirements, first we will need to rapidly deploy a VM scale set with 20 instances, and also you want to mix the VM sizes, likely because you are using both standard and sports VMs, so you can save money, and you also want zone redundancy for high availability across availability zones. And the question is, which configuration do you choose? So option A, virtual machine scale set uniform orchestration, one size only, zone redundant. And this one sounds solid at first because it gives you zone redundancy. But uniform orchestration only support identical VM sizes. This means you cannot mix spots and standards with different SKUs, and also you cannot have heterogeneous workloads. So this is violate or does not satisfy the requirement, which is asking for multiple VM sizes in the same set. Option B, virtual machine scale set flexible orchestration, multiple sizes, zone redundant. And this one is quite good actually, because flexible orchestration mode supports different VM sizes, and also you can mix spot and standard VMs and provide zone redundancy. So it's designed exactly for modern flexible workloads where you want granular control over instance types, placement, and cost optimization. So this one so far is a good answer. We will consider it and keep looking. Option C, availability set with two fault domain and two update domains. And availability sets are great for intra-data center redundancy, but there is no automatic scaling or zone redundancy, and also it doesn't support different VM sizes per se in a scale out scenario. So this is old school for VM high availability, but doesn't mean meet any of the core requirements in this case. So this one is incorrect. Option D, single VM with Azure backup and ASR, and this is wrong. Yeah, and it's yeah, just a throwaway answer. So we will keep the answer, which is option B, VM SS or a virtual machine scale set flexible orchestration with multiple sizes and zone redundant as the correct answer for this question. Question number 11. You exported a resource group as an ARM template from the portal. You want to create multiple parameterized environment from this template with minimal manual edits. Which two template sections are most appropriate to modify for reuse? Choose two. A, parameters. B, variables. C, resources to hard code names. D, output to remove all values. E, a function to disable validation. So this question is about ARM template and how to make them reusable for multiple environment with minimal editing. So before I go ahead in this question, if you are enjoying this content and if you are finding to be useful, I would appreciate it if you can subscribe in this channel, so you will be aware of our next videos, which will be also about Azure 104. And with this one, just let's start from the bottom here and see the answer. So function to disable type validation. And ARM doesn't support disabling type validation through functions. So validation is actually a good thing. So because it helps catching error, so we can keep it. So this is our wrong answer. Option D, output to remove all values. This output section is used to return value after deployment, like connection strings or resource IDs. Modifying or removing outputs has no impact on template reusability. So this one is incorrect. and it's unrelated to reuse or parameterization. Option C, resource to hard code names. And this is exactly what you should avoid, because hard coding names in resource section makes your template tied to an environment, inflexible and hard to reuse, and prone to deployment failures, because the name can be taken, right? So you shouldn't select this option. Option B, variables. And variable let you build dynamic values. For example, you can combine location and environment to name a resource. Also, you can store reusable expressions and help maintain consistency across the template with variables. Used in combination with other things, they can make the template much easier to manage and extend. So variables is correct, and option A is parameter, and you also need parameters. So parameters and variables work with each other. Parameters allow you to inject different values at deployment time, for example environment name, location, SKUs, and let you also avoid hard coding things like resource names or sizes, and support multiple environments like development, testing, production from a single template, which is very cool. So yes, A parameter, B variables, those are the two answers for this question. Moving to our last question here, and it says an internal line of business app runs on VM1 in the production subscription. You need to move the VM1 to the operation subscription without changing its private IP or data disk contents. The app has a low tolerance for downtime. What is the best approach? A. Use the move operation in the portal to move VM1 and its managed disks to the operation subscription. B. Create a snapshot of the operating system and data disks, then recreate VM1 in the operation subscription with the same private IP. C. Capture a managed image from VM1, then deploy a new VM from that image to the operation subscription and delete the original. D. Export the VM as a template, then deploy it to the operation subscription with the new VNet and the same private IP range. So here you need to move VM1 from production subscription into to the operation subscription. Requirements: first, retain the private IP. Second, preserve all data disks. 3, minimize downtime. So and the app has low tolerance for disruption, right? So let's evaluate all the options. Option A, use the move operation in the portal to move VM1 and its managed disk to the operation subscription. This is a native Azure supported operation for moving resources between subscription or resource groups. It supports moving VM along with their NICs, disks, and VNet, also retaining the private IP if the NIC and VNet are moved together. No need to recreate or reconfigure the VM, and also has a low downtime. So this one is good answer. We will consider it strongly, but let's keep reviewing the other answers. Option B, create a snapshot of the operating system and data disk, then recreate VM1 in the operations subscription with the same private IP. And this one involves manually rebuilding the VM1 from the snapshot. And the problem here is private IPs are tied to the NICs, not disks, right? And creating new NIC does not guarantee the same IP. Also, this method adds manual overhead and introduces downtime, and it's harder to automate and maintain at scale. So this one is incorrect and does not meet the low downtime or guaranteed IP requirement. Option C, capture a managed image from VM1, then deploy a new VM from that image to the operation subscription and delete the original. Similar to option B, but uses a managed image instead of snapshots. Still problematic because you are recreating the VM in new subscription and it will result in new NIC, so you cannot retain the original private IP. It also requires downtime and adds complexity. So this one is incorrect. Option D, export the VM as a template, then redeploy it to the operation subscription with the new VNet and the same private IP range. And this approach attempts to simulate the old IP by creating a new VNet with the same address range, but there is no guarantee Azure will assign the exact same private IP in this case. And even if the range is the same, the VM will get a new NIC, so the IP is still likely to change. Furthermore, this requires manual virtual network recreation, increasing deployment time and down time. So this one is incorrect, and we will go with option A, use the move operation in the portal as the correct answer for this question. So here we came to the end of our video today. Thank you so much for watching this video. I hope that you benefited from it. In our next video, we will cover domain 4 of Azure 104 exam, which will be about networking. Have a good one and good luck in your exam.